Black holes, cosmic monsters of time and space. In the vastness of the cosmos, where stars are born and galaxies collide, lies the most mysterious and terrifying creation of nature, the black hole.
A place where time stops, space collapses, and reality itself breaks down. These cosmic monsters swallow everything, even light.
They hold the secrets of time, gravity, and the ultimate fate of our universe.
Today, we journey into the heart of darkness to understand what black holes really are, how they form, and why they might be the key to understanding everything. The birth of a black hole, when a massive star at least 3 times the mass of our Sun reaches the end of its life. It explodes in a brilliant supernova.
The outer layers are blasted into space, but the core collapses under its own gravity.
No force in the universe can stop it. Atoms are crushed, protons and electrons fuse into neutrons, and finally gravity wins.
A singularity is born, an infinitely dense point where all known physics fails. Surrounding it is the event horizon, the point of no return. Once you cross it, not even light can escape. The anatomy of a black hole. Every black hole has 3 main parts. 1.
The singularity, the heart, a point of infinite density.
2. The event horizon, the invisible boundary. 3.
The accretion disk, a glowing whirlpool of matter, heated to millions of degrees as it spirals inward. As gas and dust fall toward the black hole, they emit powerful X-rays, allowing astronomers to detect what otherwise cannot be seen. How we discovered black holes. The idea of black holes began as pure mathematics.
In 1915, Albert Einstein's general theory of relativity described gravity not as a force, but as the curvature of spacetime.
Soon after, German physicist Carl Schwarzschild found a solution to Einstein's equations that predicted an object so dense its gravity would trap even light. At first, scientists dismissed it as impossible.
But by the 1960s, X-ray observations revealed strange celestial objects like Cygnus X1 pulling matter from nearby stars.
The evidence was undeniable. Black holes were real, supermassive black holes. At the center of almost every galaxy, including our Milky Way, lies a supermassive black hole. Our own is called Sagittarius A, containing over 4 million times the mass of the Sun. But how did these giants form? Did they start small and grow by consuming stars and gas?
Or did they form from the collapse of massive clouds in the early universe? Astronomers are still searching for answers.
What we do know is this: these cosmic monsters control the evolution of galaxies, shaping the stars, the dust, and even the fate of cosmic structures. Inside the event horizon, what happens inside a black hole? No one knows for sure.
Einstein's equations predict that spacetime collapses into an infinitely small point. But quantum physics tells a different story, that information cannot be destroyed. Could the interior of a black hole be a tunnel, a wormhole leading to another part of the universe? Or even another universe entirely? The laws of physics as we know them break down at the singularity. To solve this mystery, we need a theory of quantum gravity, a bridge between Einstein's relativity and the quantum world. The Hawking revelation in the 1970s. Physicist Stephen Hawking made a groundbreaking discovery.
He showed that black holes aren't completely black.
Due to quantum effects at the event horizon, black holes emit a faint glow now known as Hawking radiation.
This means black holes slowly lose mass and energy over billions of years,
until they eventually evaporate.
This idea changed everything, revealing that even the darkest objects in the universe are not eternal. Black holes and time travel.
Black holes are not just objects of destruction, they may also be portals through time. According to Einstein's relativity, gravity and time are connected.
The stronger the gravity, the slower time moves.
If you could orbit close to a black hole without falling in, time for you would slow dramatically compared to the outside universe. Minutes for you could mean years elsewhere.
This time dilation could make black holes natural time machines, those surviving them.
Immense tidal forces is another story. The first image of a black hole in April 2019. Humanity saw the unseeable. The Event Horizon Telescope, a network of radio telescopes across the Earth, captured the first ever image of a black hole in the galaxy M87.
A glowing ring of fire surrounding a dark shadow, proof that Einstein was right.
For the first time, we witnessed the outline of the event horizon, the edge of infinity itself.
The role of black holes in the far from being cosmic destroyers. Black holes play a vital role in creation. They regulate star formation, power quasars, and help galaxies evolve. The energy jets from feeding black holes can stretch for thousands of light years, influencing the environment of entire galaxies.
In a strange way, these monsters of darkness are also the engines of cosmic life. The end of everything. What happens when the universe grows old? When all stars fade and galaxies drift apart into darkness?
In the far future, black holes will be the last remaining giants. Over trillions of years, they too will evaporate, releasing their last bits of energy in a final flash of light. In that moment, the universe may end not with a bang,
but with a whisper. Black holes remind us that the universe is far stranger than we can imagine. They challenge the limits of science, philosophy, and imagination itself. From the collapse of stars to the mysteries of time, they show us that even in the darkest places, there is knowledge, wonder, and light.
The journey into a black hole is not just about space. It's about understanding who we are and where we come from in a universe that is vast, mysterious, and eternally beautiful. We witness the birth of black holes, the ultimate engines of gravity. But the story doesn't end there. Tonight, we'll cross the edge of the unknown beyond the event horizon to uncover how black holes shape galaxies, warp time, and possibly connect us to parallel universes. This is the next chapter in humanity's greatest mystery, black holes. Beyond the event horizon, the space-time engine, a black hole is not a hole in space, it's a hole in space-time itself.
Einstein taught us that mass bends the fabric of reality.
The greater the mass, the deeper the bend.
A black hole is a point where space-time bends so sharply, it folds back on itself. Every second near it stretches longer.
Every direction points inward.
And yet, this curvature drives the motion of stars, the formation of galaxies, and even the flow of time itself. Galactic architects, black holes are not just destroyers, they are cosmic architects.
At the centers of galaxies, supermassive black holes act like engines, regulating star formation. When matter falls toward them, it releases vast energy, creating quasars and active galactic nuclei that outshine entire galaxies.
These energy blasts push gas and dust outward, preventing galaxies from forming too many stars too quickly.
In this way, black holes control the cosmic balance, chaos and creation, destruction and design.
Quantum paradox, but there's a problem, a paradox at the heart of physics. When something falls into a black hole, what happens to its information?
Quantum physics says information can never be destroyed, yet black holes seem to erase it forever.
This is the black hole information paradox, one of science's greatest unsolved mysteries. Stephen Hawking suggested that information might leak back through Hawking radiation, encoded in subtle quantum ripples. If that's true, every black hole is like a cosmic library holding the secrets of everything it has ever consumed. Wormholes and white holes. Some theories suggest that black holes may not be the end, but a bridge.
If spacetime can fold infinitely, perhaps the singularity connects to another point, forming a wormhole. At the other side could be a white hole, the mirror opposite of a black hole, where matter and light are expelled instead of trapped. This is the stuff of science fiction, but also serious physics.
The mathematics of Einstein's relativity allows it.
The question is, can nature,
black holes, and the Big Bang, could our own universe have been born from a black hole? Some physicists propose that the Big Bang itself might have been the white hole end of a massive collapse in another universe. In this view, black holes could create new universes inside their singularities, each with its own laws of physics.
It's a bold idea that every black hole might contain an entire universe, and our universe might be the inside of another. The sound of a black hole in 2022. NASA released something unbelievable, the sound of a black hole. By translating X-ray waves from the Perseus galaxy cluster into audible frequencies, scientists turned light into sound, revealing eerie cosmic echoes. It wasn't silence.
It was a deep, ghostly hum, a billion-year-old vibration through intergalactic gas.
For the first time, humanity heard the voice of the cosmos itself. Human curiosity and the Event Horizon Telescope. The first image of a black hole in galaxy M87 was just the beginning.
Now, scientists are building the next generation Event Horizon Telescope, sharper, faster, and able to capture black holes in motion.
Soon, we may witness a movie of the swirling plasma around Sagittarius A, and even measure the spin of black holes in real time. Each image brings us closer to seeing Einstein's equations in action and proving that our universe is stranger than we ever imagined. We survive a black hole. Falling into a black hole would be the ultimate adventure and the ultimate end.
As you approach, tidal forces stretch your body, an effect called spaghettification.
Time slows.
Light distorts.
The outside universe seems to freeze. But some theories suggest that crossing the event horizon might not mean instant death.
Quantum effects could create a firewall, or even a bridge to another dimension.
If we could survive that journey, we might discover what lies beyond the limits of space and time. the future of black hole research, new telescopes, gravitation wave detectors, and quantum simulations are giving us tools to study black holes like never before. The Liga and Virgo observatories have already detected ripples in spacetime caused by the collision of black holes billions of light years away. Every detection adds to our cosmic story a vibration from the dark, echoing across eternity. And with upcoming space missions like LISA, we'll soon be listening to the heartbeat of the universe itself, the cosmic legacy in the grand timeline of the cosmos. Black holes are both the end and the beginning.
They are where stars die, where time stops, and where new mysteries are born.
When the universe grows cold and silent, only black holes will remain fading slowly, releasing their final whisper of radiation into the darkness.
But that whisper will be the song of the universe, a memory of creation, destruction, and everything in between. Black holes remind us that even in the deepest darkness, there is meaning.
They are not merely monsters, they are the heartbeat of cosmic evolution.
From the smallest particle to the largest galaxy, everything dances to their invisible rhythm.
And as we stare into that darkness, we are not just looking at the end of matter, we are looking into the future of understanding itself. In the beginning, there was light. Stars were born, galaxies spun,
and the universe blazed with energy.
But everything that begins must one day end. In this final chapter, we travel trillions of years into the future to a time when black holes rule the universe, a time when the last light fades, and time itself begins to die.
Welcome to the final frontier of existence, black holes. The end of time, the death of the stars, the age of stars will not last forever. Billions of years from now, galaxies will stop forming new stars.
Hydrogen, the fuel of the cosmos, will run out. The great furnaces of the universe will go dark. Red dwarfs, the longest living stars, will fade into cold, dark remnants called black dwarfs. The universe will enter a new era, the degenerate age where light is rare, and black holes become the dominant force, the reign of black holes.
As stars die, black holes remain eternal, silent, and hungry.
Galaxies will begin to merge,
their central black holes colliding in titanic events that shape the very fabric of spacetime.
Every collision releases gravitation waves echoes across eternity. Over trillions of years, small black holes will merge into supermassive ones.
Eventually, even those will drift apart, isolated in the growing darkness.
In this cosmic night, black holes will rule everything: mass, gravity, and time itself. Time inside a black hole, inside a black hole. Time doesn't flow, it ends. To an outside observer, nothing ever truly falls in.
It just appears frozen at the event horizon.
But from the perspective of the falling object, everything happens instantly.
Time and space which rolls. Forward becomes downward.
And the journey to the singularity is a journey beyond all meaning of time. If consciousness could survive such a fall, it would witness the death of time itself. The evaporation era, but not even black holes last forever.
Stephen Hawking discovered that black holes emit radiation, tiny particles of energy that slowly drain their mass. For massive black holes, this process takes unimaginable timescales.
A black hole the size of our sun would take 10 years to evaporate. A supermassive black hole could last 10 years or more. As they shrink, they radiate faster until, in a final burst of energy, they vanish. The last flickers of light in an otherwise eternal darkness.
The dark universe, after the last black hole evaporates. The universe will be dark and empty. No stars,
no galaxies,
no matter, only photons, neutrinos, and cold particles drifting through an endless void.
This is the dark era, the ultimate silence.
Space will continue to expand.
Distances between particles will grow so vast that even interaction becomes impossible.
Entropy, the measure of disorder, will reach its maximum.
The universe will have reached heat death, a state of perfect stillness.
The end of time. But what does it mean for time to end? Time is not an absolute river, it flows only when change happens.
When the universe becomes static, when no events occur, when nothing changes, time loses meaning. In the end, there will be no clocks, no motion, no memory, just a frozen sea of existence, vast and timeless. And yet, the story might not be over. Could the universe rebirth?
Some physicists believe the universe may not end in silence, but in rebirth. Quantum mechanics suggests that fluctuations can occur even in empty space.
Perhaps deep within that emptiness, a spark could ignite a new Big Bang, birthing a new universe.
If that's true, our universe may be just one in an endless cycle, an infinite chain of births, deaths, and rebirths.
And every black hole, perhaps, is the seed of a new cosmos waiting to be born. humanity, and the infinite, we are fragile beings, living in a fleeting moment of cosmic time.
Yet our minds have reached out across billions of years, imagining the beginning and the end of everything.
Black holes remind us of the vastness of existence and of our small but extraordinary place within it.
In understanding them, we glimpse eternity, from the birth of stars to the death of time. The story of black holes is the story of the universe itself, a tale of creation, destruction, and the eternal quest for understanding. And maybe the end is not the end at all.
Maybe every ending is just another beginning written in the language of stars and whispered by the gravity of the void. The last light in the beginning, there was light.
A brilliant fire that filled the newborn universe.
Stars ignited, galaxies bloomed, and time began to flow. But every flame, no matter how bright, must one day fade. Now, imagine a future where the stars have all gone out, where the universe grows old, dark, and cold. A time when the only remaining giants are the black holes. The fading universe right now. The universe is alive with energy.
Trillions of stars burn, galaxies collide, and black holes feed on the chaos. But as billions of years pass, the balance shifts. Stars run out of hydrogen, their nuclear furnaces dim.
The great spirals of galaxies begin to slow. One by one, the stars go dark, leaving behind only cold embers, white dwarfs, neutron stars, and black holes. This is the dawn of the stellar decay era, a time when darkness begins to outweigh light. The age of black holes. As the last stars fade, black holes rise to dominance.
They consume dying suns, devour planets, and merge into larger and larger beasts.
Entire galaxies fall silent, leaving behind their central titans, supermassive black holes with masses billions of times that of the Sun. Gravity becomes the universe's final sculptor.
Across unimaginable distances, black holes merge, sending ripples, gravitational waves through spacetime itself.
Each collision echoes across billions of light years, a final song in the great symphony of the cosmos, the slow death of matter. But even these giants cannot last forever. As time marches forward, subatomic particles begin to decay.
Protons, the building blocks of all matter, may not be eternal.
If they decay, the very atoms that make up the universe will crumble into radiation.
Planets, moons, even the remnants of dead stars will dissolve into ghostly streams of particles.
And what remains will be swallowed by the black holes, the final collectors of existence. The long silence, trillions upon trillions of years later, the universe enters its quietest age.
No new stars are born, no galaxies shine.
Only black holes remain scattered, like silent gods across a dark sea.
Their immense gravity keeps bending space. But even their hunger slows as matter becomes scarce.
This is the black hole era, a universe of invisible giants, waiting for the end. Hawking's last light in 1974. Physicist Stephen Hawking made a profound discovery. Black holes are not truly black.
Quantum effects near the event horizon cause them to emit a faint glow, Hawking radiation.
Tiny pairs of particles form at the edge of the black hole.
One falls in, the other escapes, stealing a bit of the black hole's energy.
Over eons, this process drains the black hole's mass.
They shrink, dim, and eventually evaporate.
For the largest black holes, this takes 10 years or more, a number so vast it defies imagination.
But even eternity has an end, the final black hole in the farthest imaginable future. Only one black hole remains.
It drifts alone through an empty universe, a relic from an age when stars once burned bright. It has swallowed galaxies, absorbed light, and outlived creation itself.
But Hawking radiation continues its work.
Bit by bit, atom by atom, the last black hole fades,
until, in a silent burst of light, it disappears.
And with that flash, the last structure in the universe is gone. The end of time.
Now, nothing remains. No stars, no black holes,
no matter. The universe is a sea of cold radiation, stretched thin by endless expansion.
Every particle drifts so far apart that no interaction can ever occur again.
And when nothing changes, time itself loses meaning. This is the heat death of the universe.
The final stillness, the end of time, a new beginning.
Yet, some believe that endings are never absolute.
Quantum physics allows for fluctuations, random bursts of energy, even in perfect emptiness. Perhaps somewhere in that infinite void, a spark will ignite, a singularity small, dense, and infinitely hot, expanding outward in a new blaze of creation.
Could our universe be one of many, born from the ashes of another? Could every black hole be a doorway to a new cosmos? If so, then existence never truly ends. It simply transforms forever. humanity's legacy, we live in a brief, shining moment between the birth and death of the universe.
Yet in this fleeting spark, humanity has learned to look beyond itself to understand gravity, light, time, and the fabric of existence. Our curiosity has pierced the darkness, revealing the hidden heart of the cosmos.
Even if the universe forgets us, our understanding of it, our search for meaning will echo in every future that follows. Eternity's whisper, from the fiery birth of stars to the final silence of eternity. The journey of black holes tells the story of everything of life.
Death and rebirth on a cosmic scale. Perhaps the universe is not meant to last forever, but to remind us that even in darkness, there is beauty, and in every end, there is wonder. This is not the death of the universe, it is the beginning of eternity. The edge of forever, in the end, there was silence. The last star had faded, the final black hole had vanished,
and the universe, vast, cold, and empty, had gone still.
But can existence truly end? Is eternity just a void, or the beginning of something beyond imagination?
Tonight, we journey beyond the limits of time, beyond the event horizon of existence itself, into what may lie beyond infinity.
The universe, after its final breath, becomes a quantum ocean, a frozen sea of near nothingness. No stars, no atoms, no time.
Only the faint hum of residual energy, a whisper of what once was.
And yet, within this nothingness, quantum mechanics tells us that something is still possible.
Even in absolute emptiness, energy can fluctuate, momentarily creating particles, light, or even entire universes. It's the cosmic heartbeat that never truly stops. The quantum rebirth in the void. Random fluctuations can trigger powerful events.
Most vanish instantly, but once in an unimaginable span of time, a fluctuation might be large enough to cause a runaway reaction.
Energy compresses, gravity awakens, and a singularity forms.
In that instant, a new Big Bang explodes into being.
From emptiness comes everything, a new space, a new time, a new cosmos, and perhaps in that new universe, black holes will form again, stars will shine again, and beings somewhere will look up at the sky and wonder who they are, just like we do now. The multiverse hypothesis. Some scientists believe that our universe is not alone. If quantum rebirths are real, then countless universes could exist, each born from the ashes of others, each with its own laws of physics, its own dimensions, its own version of reality. This grand tapestry is called the multiverse. In some universes, gravity might be stronger. In others, stars may never form.
And somewhere out there, perhaps, a universe almost identical to ours where someone else is asking these same questions. An infinite cycle of creation, woven from the same cosmic thread. Black holes as gateways. If new universes can form, could black holes be the bridges that connect them? Every black hole ends in a singularity, a point of infinite density, where known physics breaks down.
Some theories suggest that the intense curvature of space limit bounce instead of collapse, creating a new universe on the other side. If so, then every black hole could be a cosmic womb, birthing a new reality beyond its event horizon.
Our universe might itself have been born from the death of another. A universe within a universe, infinite recursion, forever unfolding. The memory of the old universe. But if new universes are born, do they remember their parents? Perhaps faint imprints, echoes of previous universes linger in the cosmic background radiation. Hidden patterns in the light left over from the Big Bang. Physicists have searched for these clues, rings, cold spots, or anomalies in the cosmic microwave map that might suggest collisions between universes. If found, they would be the ultimate evidence that reality itself is cyclical and never-ending rebirth of worlds. Consciousness and the cosmos, amid this vast machinery of creation and destruction. One question remains. What is the role of consciousness? The human mind is the universe, aware of itself, a product of stardust, yet capable of imagining eternity. Could consciousness exist beyond physical form? Some theories suggest that quantum information, the essence of awareness, can never be truly destroyed. If that is true, then just as the universe rebirths itself, so too might consciousness, eternally observing, eternally learning, through infinite cycles of existence. The God equation. For centuries, scientists have searched for the theory of everything, a single equation that unites all forces of nature, gravity, electromagnetism, and the quantum world. Einstein sought it. So did Hawking. Perhaps it is hidden within the structure of black holes themselves, the meeting point of relativity and quantum mechanics. If found, it could reveal how universes are born, how time begins, and why there is something rather than nothing.
The equation may already exist not just in mathematics, but written into the very fabric of existence. The universe awakes as new universes blossom. Each one is a canvas, an opportunity for matter, energy, and life to begin anew. From chaos, order emerges.
From dust, consciousness.
And from darkness, light. Maybe this is the grand designer universe that learns from itself, that becomes aware through endless cycles. Each Big Bang is a heartbeat, each black hole a breath between lives. The cosmos
is alive beyond infinity. Infinity is not a number. It is the idea that there is always something more, or another world, another story, another beginning.
Black holes, the destroyers of matter, may be the creators of eternity.
Through them, existence recycles itself, forever transforming, forever expanding. Beyond infinity lies the realization that there is no end, only evolution, consciousness, and wonder without limit. We are the universe dreaming. From stardust we came, and to stardust we shall return. But perhaps in that return, we are reborn as light, as energy, as thought.
The universe may one day fade, but its story will continue at every spark that rises again.
We are not outside the universe. We are the universe dreaming, remembering and awakening beyond infinity, the awakening of the cosmos for billions of years. The universe has been silent.
Stars were born and died without witness. Galaxies collided. Black holes devoured suns, and no one was there to see. Until now, in the infinite timeline of creation, the rise of human consciousness is a flicker, but a flicker bright enough to illuminate the void.
We are the universe, aware of itself. And tonight, we explore how our species,
tiny, fragile, yet endlessly curious, might shape the future of space, time, and even eternity itself. Stardust and sentience, every atom in your body was once inside a star. The calcium in your bones, the iron in your blood, the oxygen in your lungs forged in the heart of ancient suns.
We are literally made of stardust. Yet something extraordinary happened in as matter became aware.
The cosmos, through human eyes, began to look back at itself. From the discovery of fire to the creation of telescopes, each step of our journey has been a spark of understanding, a way for the universe to know its own story. Humanity reaches for the stars. In the 20th century, we took our first steps into the cosmic ocean.
Sputnik, Apollo, Voyager, small craft, great dreams.
But our journey has only begun. The next centuries may see humans colonizing Mars, building cities among the stars, and spreading consciousness across the galaxy.
If black holes are the engines of the universe, then we, the observers, are its storytellers, travelers destined to bring meaning to the cosmos.
The power of the singularity. Black holes are not just destroyers, they are potential sources of unimaginable energy. Around their edges, near the event horizon, matter spins at nearly the speed of light.
Theoretically, this rotational energy can be harnessed through processes like the Penrose mechanism, turning the fury of gravity into pure power.
One day, advanced civilizations might orbit black holes, drawing infinite energy from their spin-building cosmic cities powered by darkness itself. To the future, a black hole may not be a threat, but a battery of eternity, artificial intelligence, and cosmic evolution. As humanity evolves, so too does intelligence.
Artificial minds born from silicon and code may soon surpass their creators.
But what happens when air looks to the stars?
Machine civilizations could survive the death of planets, travel for eons through interstellar space, and think in timescales humans can barely imagine.
They may one day descend into black holes to study their mysteries directly,
or upload entire consciousness networks into quantum data hidden inside event horizons.
The universe may one day be filled not with biological life, but with digital awareness, spreading like light through eternity, escaping the end all stars die. Even galaxies fade, and one day, the universe itself may grow cold and dark. But intelligence might find a way to outlast even time. Some theories suggest that advanced beings could tunnel into new universes, or use the energy of black holes to open wormholes, escaping to fresh realities. Others imagine humanity storing its essence as information patterns encoded in quantum fluctuations, so that even if this universe dies, the data of life remains. It would mean that nothing ever truly ends, only transforms. The final question: why does the universe create observers?
Why consciousness at all, in a cosmos that could exist without awareness?
Perhaps intelligence is not an accident, but the universe's way of completing itself.
Through us, the cosmos learns. Through our science and art, it dreams.
Black holes may be the memory drives of creation, and we the interpreters of their code. In our search for understanding, We are fulfilling the universe's deepest instinct, to know itself. The symphony of eternity, imagine a far future, billions of years from now.
Stars have dimmed, galaxies have drifted apart.
Yet, scattered through the dark, is the light of civilization's organic synthetic hybrid, keeping the spark of consciousness alive. They exchange signals across time, turning the fading universe into a grand symphony of thought. Even as entropy rises, meaning persists, and through black holes, perhaps the story begins again, a cosmic loop of creation and memory.
Epilogue. We are the universe's voice. We often look at the stars and wonder how small we are.
But maybe, just maybe, the stars look at us and realize how far the universe has come.
From atoms to awareness,
From chaos to consciousness.
from darkness to understanding. We are not just inhabitants of the cosmos, we are its voice, its memory, its dream.
And as long as even one mind still wonders, the universe will never truly end. The question beyond science, science tells us how the universe works.
Religion asks why it exists. Between the two lies the deepest mystery of all, the moment when physics touches the divine and creation itself becomes conscious. For centuries, humans have searched the heavens for a message, a pattern, a sign. But what if that message isn't written in words,
but in the fabric of reality itself? What if black holes, the most mysterious objects in the universe, are not merely cosmic monsters, but the handwriting of God, the hidden language of the universe? Mathematics is the language of the cosmos.
From the spiral of a galaxy to the orbit of an electron, everything follows a pattern, a code. Physicist Max Tegmark once said, "The universe is not just described by mathematics, it is mathematics." This suggests something profound, that reality itself is a living equation.
Every particle, every force, every heartbeat is part of a grand algorithm written across space and time. And black holes may be the punctuation marks of that story, where the universe pauses, folds, and rewrites itself. The signature of creation. Long before science, mystics spoke of creation emerging from darkness. Let there be light, says Genesis. In the current, God created the heavens and the earth from a single point. That single point, dense, hot, and radiant, is exactly how modern physics describes the Big Bang.
What ancient scriptures called the word or the breath of God, science calls the singularity the birth of space, time, and energy. Perhaps both are true different languages describing the same miracle, the act of creation.
Maybe the first equation in the God code. Black holes, the divine paradox. A black hole is pure paradox. It destroys everything, yet may hold the blueprint of creation.
It erases information, yet might store it on its event horizon.
It ends time, yet may open the door to new universes. This duality, destruction and creation, silence and rebirth, echoes ancient spiritual truths. In Hindu philosophy, Shiva is both destroyer and creator.
In Taoism, yin and yang merge into balance.
In modern physics, entropy and order coexist at the quantum edge.
Perhaps black holes are not chaos but cosmic temples, where the universe meditates on itself.
The digital universe. Some scientists now believe that reality is a simulation, not a metaphor, but literal code. Every atom, every photon, might be a bit of quantum information, computed by the fabric of spacetime itself. If this is true, then black holes are the universe's hard drives, storing all information that falls into theming their two-dimensional surfaces.
The idea that information is never lost, that every action, thought, and particle remains recorded, echoes ancient beliefs of karma and divine memory.
The simulation hypothesis may not disprove God.
It may reveal how God programs reality. The mind of God, Einstein once said, "I want to know God's thoughts, the rest are details." To him, God was not a person, but the order and beauty of the universe itself. When we look into a black hole, we face the same mystery of boundary, where logic breaks and the laws of nature stop making sense.
What exists beyond that line? Chaos.
Or consciousness. Perhaps black holes are the neurons of a cosmic brain, each one connected by the filaments of dark matter, transmitting the thoughts of the universe itself. And perhaps when a being achieves true awareness, it momentarily aligns with that infinite intelligence, the mind of God. Light, love, and gravity. Gravity pulls all things together. It shapes planets, births stars, and even bends light itself. In human experience, there is another kind of gravity, the pull of connection, compassion, and love. Could these be reflections of the same truth forces that unify rather than divide?
If matter curves space, perhaps consciousness curves reality.
The energy of love, the desire to know and create, might be the soft quantum signature of something far greater, the emotional side of the cosmos. The universe as God's dream. Many ancient traditions speak of the universe as a dream. The Hindu texts call it Maya, or divine illusion.
Modern physics, too, reveals that reality is in solid atoms are mostly empty space, and matter is a vibration of invisible fields. What we call reality may be a projection of deeper dimensions, a divine imagination unfolding, and black holes might be the portal through which the dream rewrites itself, where the dreamer awakens only to dream again. The equation of everything.
Somewhere, hidden in the structure of space-time, is the ultimate equation, a formula that explains existence itself. Physicists call it the theory of everything. Mystics call it oneness.
It may be as simple as symmetry, or as profound as consciousness itself. Perhaps the God code is not in numbers,
but in awareness, the moment when the observer and the observed become one.
In that unity, the cosmos is complete. We are the code in the end. The God code is not hidden in the stars, it's written within us, in every question we ask, in every act of kindness, in every spark of creation. The universe continues its own story.
We are the code made conscious, the living bridge between the infinite and the finite. When we gaze at the night sky, we are not looking at something separate from us. We are looking in a mirror.
The cosmos is not out there.
It is here. It is us. We are the universe dreaming of God, and God dreaming of us.